All right, derivative of trigonometric functions, 3.5. So here are 6 new derivatives. These have to be memorized. The derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. The derivative of tangent x is secant squared x. The derivative of cosecant x is negative cosecant x cotangent x multiplied, right? Secant x, the derivative of that is secant x times tangent x. And then finally, the derivative of cotangent x is negative cosecant squared x. And that is on that blue reference sheet that I gave you. So these are the derivatives we're going to use today on this lesson. Okay, so example 1, find dy dx if y equals 2 over sine of x. Before I start, there are some things that I want you to write down on your notes. These are reminders. So I'm going to pause, I'm going to write it down, and then I want you to write it down. All right, so these are the reminders that I wanted to write down, and I want you to write them down in your notes. For example, sine of x is the reciprocal of cosecant x. So sine x equals 1 over cosecant x, and cosecant x equals 1 over sine x. Cosine x is equal to 1 over secant x, and secant x is equal to 1 over cosine x. These are all reciprocal functions. Tangent goes with cotangent, but then of course, tangent is also sine of x over cosine x. So that means that cosine or cotangent is just a reciprocal of that, so cosine over sine. And you'll actually need these two for, well, actually for cotangent, secant, and cosecant, you'll need to know the reciprocals for the calculator, because if you've looked on the calculator, there is no cosecant, secant, or cotangent. And then finally, one of the most important identities that you will ever learn, sine squared x plus cosine squared x equals 1. Okay, so now I'm going to do the problem. Hopefully you have written this down. Okay, find dy dx if y equals 2 over sine x. So first off, I want to rewrite that. I'm going to rewrite it as 2 times 1 over sine x. And then I'm like, oh, 1 over sine x is equal or equivalent to cosecant x. So this is actually 2 cosecant x. And now that I've rewritten it, I can actually go ahead and derive this. So dy dx, right? So 2 times whatever the derivative of cosecant x is, which is negative cosecant x cotangent x. And of course, you know, the negative and the 2, you could write those together in the front, please. Cosecant x cotangent x. And there you go. There's my derivative. Okay, example 2. Here we're using the product rule. Find the derivative of y equals 3x squared times sine x. So I need you to be able to decipher product rules with trigonometry. This is u, this is v. So same old, right? And in case we forgot it, I'll write the product rule up here. Okay, so u is 3x squared, so u prime is 6x. V is sine x, so the derivative of sine is cosine. All right, so I'm going to derive. Regular old product rule, just with trig now. No big deal. So u is 3x squared times v prime, which is cosine x, plus v, which is sine of x, times u prime, which is 6x. And then simplify a little bit. Actually, nothing to simplify. Just, I can rewrite everything without the parentheses and bring the 6x to the front. And there's my derivative. All right. Oops, skipped the example 3. Find the derivative of y equals 2x times cosine x minus 2 sine x. So I need you to be able to see that this is a product rule in the front here. Okay, this will be u times v. And then the rest is just regular. I'm just going to derive that normally. It just happens to have a coefficient in the front That's no big deal. So the derivative is going to be u times v prime. So u times v prime, and the derivative of cosine x is negative sine x plus v, which is cosine x, times u prime, which is a 2. So this right here is my product rule. And then minus 2 times, okay, what is the derivative of sine x? It is cosine x. This thing is writing slow. Don't know why. Okay, so basically that's it. Simplify a little and, or, you know, write the numbers in the front and the negatives and stuff like that. So I have, let's see, negative 2x sine x, and then plus 2 cosine x, and then minus 2 cosine x. And then, ooh, looky, looky. These cancel out, right? And so my answer is just that. And that's it. All right, example 4, using the quotient rule. Let me write the quotient rule down just for a reminder's sake. Okay, so I wrote down the quotient rule just to remind us, right? I can do all the pieces too, if it helps. So u is cosine x. U prime is the derivative of that, which is negative sine x. V is the bottom part, 1 minus sine x. And then v prime, so the derivative of 1 is 0. And then I have a negative sine x. So the derivative of a negative sine x is going to be a negative cosine x. This is going really slowly. Okay, so there are my pieces. I can just derive now. I'll do it in black. So y prime, or dy dx, or whatever you like. So it's v. So that's 1 minus sine x. V times u prime, which is negative sine x, minus u, which is cosine x, times v prime, which is a negative cosine x. And then all of this is above v squared, right? Low d high minus high d low over low times low. All right, next step would be to simplify this a little, whatever can be simplified. So let's see. 1 minus sine x times negative sine x. So I'm just going to go ahead and distribute the negative sine x. So I get negative sine x minus a negative, see, a negative times a negative, right? So it's actually going to be positive sine squared x. And that's the first part. Okay, minus, and then I do the second part. I have cosine x times negative cosine x. So let me write this down. This right here is basically a negative cosine squared x. But then with that negative right there, it becomes positive, right? It's supposed to be an arrow, and it doesn't look like one. Close enough. Okay, so that's basically negative cosine squared x, but with the other negative, it becomes positive. So now I have a positive cosine squared x. And then all of this is above my low times low. Oops. Forgot my x. Minus sine x. Okay. All right. Now, I need to be able to quickly pick out the fact that, ooh, these right here, that's that special trig identity. It's a Pythagorean identity. Sine squared x plus cosine squared x are actually equal to 1. So now, what I actually have on top, let me write the 1 first. 1 minus sine x. I hope you can see why I decided to write the 1 first. Over 1 minus sine x squared. So I have 1 minus sine x on top, and I have 2 1 minus sine x's on the bottom. So this cancels out, and one of these cancels out. And my answer is now 1 over 1 minus sine x. And there you go. All right, example 5. A higher order derivative. Remember, see how it has like 2 little, what are they called? Apostrophes? This is the second derivative. Derivative. Okay? So, to start off, let me find the first derivative. So y prime of secant x, right, is just secant x times tangent x. That is my first derivative. Now I must repeat the process. Right, I must do the second derivative. But I have to realize, oh, this is a u times v. So I will be doing a product rule. So y prime, or y double prime, is going to be u times v prime plus v times u prime. So u times v prime, so that's the derivative of tangent x, okay? And the derivative of tangent x is secant squared x, plus v, which is tangent x, times u prime, which the derivative of secant x is basically that whole thing again, times secant x tangent x. Almost didn't fit. And that's it. That's my second derivative. Clean it up some. Let's see. I have 1 plus, or times 2 more for a total of 3. So secant cubed x plus, I'll bring the secant x to the front. And then tangent x times tangent x, that's a tangent squared x. And that's that. Next. All right, this is the last problem. It's going to take the longest because I'm going to show you stuff on the calculator. Okay? So, find an equation for the lines that are tangent and normal to the graph of f of x equals tangent x. So the word normal is perpendicular, basically. And so I'm finding equations. And for this line, for the normal line, the slope is not going to be the exact same slope as my function, f of x. It's going to be the opposite reciprocal. So opposite reciprocal. And then for tangent, that's what we've been doing, right? Whatever the slope is for my f of x, I'm going to use the same slope for my tangent. And I did realize that I am missing a piece of the sentence. I guess I stopped typing. Let's make that period into a comma. And if you would add at x equals 2, I actually need a value. My bad. All right, so to write an equation, you need 2 things. You need a point. That's my x equals 2. It'll get me my y. And you need a slope. Well, the way we're going to find the slope is we're not going to derive this using quotient rule. I want to do it on the calculator, right? Because you do need to know how to do that as well. So I'm going to derive tangent x over x on the calculator numerically and plug in 2, and the calculator is going to give me the answer. And I'm going to show you how to store if you don't know how to store. Okay, so calculator. I'm going to go to math, number 8, because it's n derive. And then I get all this stuff, right? It's c over d, and then I need to put an x because I'm deriving with respect to x. In the parentheses goes my function, so tangent x, close that parentheses, and then divide by my x, and that's the function. And then towards the end, x equals what? It equals 2. Note my steps on the left here. Hit enter. And there's my answer. Now look at that answer. Not fun. You're not supposed to actually round until the end of your whatever you're doing. If you want to be lazy and you don't want to store, then I suggest writing down as many numbers as possible. In the end, you do have to round to 3 decimal places. So if you're going to use this in the middle of an equation, use as many numbers as possible if you don't want to store. You don't have to store. You won't die if you won't store. But don't use 3.433. Use like 3.433, That's pretty safe. Okay, so now we're going to store. I'm going to write down the steps, and I want you to write them down in case you need to look back at this, and then I'm going to do it. Okay, so first let me pause. Okay, so I wrote all the steps on the right. In purple are the buttons you would hit to store a number. In green is how you would recall that number. If you already know how to do this, then great for you, right? If you don't, then you've learned something new. If you don't want to do it at all, then write down really long decimals, go ahead. I'm not forcing you to do the store and recall process. Okay, so there's my answer, right? 3.4334789. Okay, I don't want to write it down, so I'll hit the store, or I'll use the store function in the calculator. I'm going to hit the store button. It's down here. So it has answer because it's like, yo, oh, the answer from above. Okay, so store, and then I'm going to hit alpha. And the reason I'm hitting alpha is because I'm going to store it in one of the letters. A is the first thing that pops up, right? So in order to use A, I'm going to press the math button. You see how there's a green A with the math button? So that's where I'm going to store it. And then just hit enter. So now that's stored. So whenever I want to recall that, all I have to do is go back to alpha A, okay, or alpha math. All right, so I'm done finding my slope. To write an equation, I also need a y value. Okay, so I'm just going to plug in my x equals 2 into my function. My function was tangent of x divided by x. So tangent 2, close parentheses, divide by 2, which is x. And I'm pretty sure I'm in the right mode, but let me make sure. I'm in radians mode, so okay, I'm good. All right, so there is my y value. Again, a long decimal. So I'm going to go ahead, I'm going to clear all my press history here, and I'm going to go ahead and I'm going to store the y value because I don't want to write all those numbers down. So I'm going to hit store, so it's answer, and then alpha, because I'm going to store it in one of the letters. I already used A, that's where my slope is, so I'm going to use the next obvious choice, which is B. It's the APPS button, the apps button, applications. So now it's in B, and I'll hit enter just to make sure, and there it goes. Okay, so 2 very long decimals are stored in the calculator, so I don't have to write them down and be worried, oh my god, did I round to enough spaces? Okay, so the next step is to write the actual equation. Right, now, writing the actual equation. I'm going to do the tangent one first. Okay, so normally the equation is y minus y1 equals m times x minus x1. Okay, I'm going to manipulate this so that it's already in y equals mx plus b form, in slope-intercept form. So I have y equals, let me just go ahead and distribute that m. So m times x minus m times x1. And then the y, the minus y, this right here, minus y1, that should be added to the other side. Okay, so plus y1. Okay, so now that I've manipulated it without actually plugging real numbers in, I can go ahead and use my store function in the calculator with those really long decimals and get an accurate answer. Okay, so now writing the real equation. So y equals, right, my slope, which was, hold on a second, 3.433. In this class, you just have to round to 3 decimal places, so 3.433x minus. Now here's the tricky part. See this stuff right here? I'm going to go ahead and do all of that in the calculator because I don't want to multiply decimals and stuff. So I'll just do it in the calculator. Now remember, x1 was 2 from up here. Okay? So what I'm going to do is I'm going to use my recall from the storing that we did, and I'm going to do the slope times 2 plus my y value. So, all right, I'm going to clear this. So my slope, and so I'm going to hit second because I want the recall, which is basically the store button. Recall, and then, okay, it's asking me what are we recalling, basically. So I'm going to hit alpha, and then, okay, so it's slope. So slope, we save that under the A, which is math. Okay, and enter, and there's my number. And I'm multiplying my slope times my x1, which was 2, so times 2. And then I'm supposed to add my y1. So add, and then my y1. So y1 is the y value that we stored in or under the letter B. So second, recall, which is the store button. And then it's asking me, okay, what letter, right? So alpha. And then I'm going to hit the apps or the application button for B. And then hit enter. And there's my m times x1 plus y1. And I don't have to actually compute it. The calculator is going to do it for me. Hit enter. And there's my answer, 5.774. So I come back over here, and it's 5.774. It was positive, right? Yeah, it was. And there's my equation. That's for the tangent. Okay? I'll write tangent. Now you need to do the normal. Normal, the only thing that's going to be different is that the slope is not going to be the 3.433. For the normal, or the perpendicular line, the slope is going to be the opposite reciprocal. So a negative 1 over 3.433. Okay? And you can put that all in parentheses when you do it on the calculator. So that's going to be my slope. So I'm basically going to do the same stuff. I want you to go ahead and try it. So I'm going to still do it, but I want you to try to see if you can figure it out. The equation thing is going to be the same, right? Just like this one, with some modification. So it'll be y equals 1 over m, and it's going to be a negative reciprocal, so I have to make something negative, right? Times x minus, and then that's going to be altered just slightly. The x over, or x of 1 is just going to be on top of my m, right? But remember, my slope is negative, so the minus becomes positive right there. And then plus my y1. That doesn't change. So you're going to do it this way. I suggest, however, let me give myself a little bit more space. Just to be safe, parentheses. Okay, parentheses are a good idea. So I'm going to stop, and then I'm going to show the work. I urge you to stop and try to do it yourself. Okay, I realized that earlier when I was trying to show you about putting this in, I neglected the negative in the front. So the negative should have been there. So that negative with this number, which was negative also, makes this a total of a negative 7.959. Okay, so I fixed that. So if you're wondering, that's what happened. Okay, down here, this is the final answer. So I'm going to switch back to the calculator to show you the steps of how I manually entered this, the pieces here to get the negative 0.510, right? And how to get the negative 0.291. All right, so here are all the steps that I did on the calculator to do the x1 over m. So that's 2 over the slope plus y1, which is a negative 1 point whatever, whatever, whatever. And I get my negative 0.510. So now I'm going to go ahead and figure out what the slope is when it's the opposite reciprocal. So negative 1 over the 3.433. I need a decimal for that. Okay, so there are my steps. I did the negative 1 over the slope, and I got negative 0.291249. So those are the pieces to my equation. So negative 2.91x minus 0.510. Okay, hope you learned something. That's it. Please do your homework. Have a good weekend.